Greetings and welcome, friends. We've talked about in previous lessons the idea of normal distribution, which is a bell-shaped curve, also called a normal curve, that is symmetric about the mean. And if I talk about areas under the normal curve, we can see that roughly 68% of the values land within one standard deviation above or below the mean. This little symbol here is the Greek symbol mu, and kind of pronounced like what a cat might say. And you also could call that x bar. That's our measure of center, our mean. And this symbol is sigma, which is a standard deviation, which describes the average amount, roughly, that my data is from the mean, that I will have 68% of my data one standard deviation above or below the mean. If I allow myself to go out two standard deviations, notice two standard deviations above or below, I end up with 95%, roughly. And if I allow myself to go out three standard deviations, I'm starting to cover more and more of my data, and I get 99.7% of that data. Here's actually another representation of the same thing. If both halves of these are 68%, then one half is 34%, right? Okay. And then if I want just this sliver here, it turns out that's about 13.5%. This is about 2.35%. And then I get smaller and smaller percentages in the remaining space. Okay? So that is a distribution of the probabilities for standardly deviated data, right, is how that works. So how do I use those probabilities? Look at this. I've given you a nice little graph to work with. It says normal distribution has a mean mu, okay, and a standard deviation sigma. All right. Sometimes we'll be given numbers. Sometimes we'll be given the general representations here. It says an x value is randomly selected from the distribution. What is the p? They're talking probability that it is between two standard deviations less than the mean and the mean. Okay? So what space, what region are they describing? They're describing two standard deviations below up to the mean, up to the middle. All right, Ethan? So this is the region that they're describing. Now, how could I use my little chart here to help me find this space? What do you guys think? How could I use my chart to find the percent that would land between these two values? So this is oh, I forgot, mu, man, minus 2 sigma all the way up to mu are my boundaries. So if I want to find the percent that lands between those, notice I know that two standard deviations below and above is 95%. So what would I do if I just wanted below? Now, we were already told that this is symmetric about the mean. That means that this graph looks the same on the left as it does on the right. So if I want just this part of the data, how do you think that part is going to relate to that 95%? It's going to be exactly half of it, right? Does that make sense? Visually, do you guys agree that this is half of that two standard deviation away bell shape? All right. I don't know if anyone's even looking, but that's okay. My internet friends are here, and that's fine. I'll teach someone in the future. So here we go. So one way I could find this is I could figure out this probability is going to equal half of 95%. And what's 95 divided by 2? 47.5%. No, I used a calculator. All right, Ethan, you can put those down then. Thanks. All right, another way I could have done that is using this version of the chart. What was the same problem represented in this version? It would have been this spot and this spot. So I would want to add 34 to 13.5, which notice is also 37.5%. Yeah, add them or subtract them or cut them in half. That's what we're going to do. We're basically working with like areas, and we're either adding or subtracting or dividing them is what we're doing. Okay, so this space represents 47.5%. The alternative approach that I just did was, it was also the same as the, what was it, 34%, half of 95%, yep, was 47.5, plus 13.5% was also 47.5%. So yeah, so depending on which kind of version of that I want to use, I'll still get the same result, right? Not too shabby. It's a little bit weird getting used to the way this is written, but it'll work just fine. Let's take a look at the monitoring progress questions. All right, so question 1 and 2 here. Let's see, can I give myself enough space here? Oh dear, where did I go? All right. Well, the curve for normally distributed data is always the same shape. It might be a little bit, it might have different numbers on it, but yeah, the shape is always going to be the same, which is why it's normally distributed. It's kind of the normal outcome here. Here we go. So I'm finally caught up to you guys. So what percent of the data is less than or equal to the, what does this symbol mean? I just gave it away. Mean. It means the mean. So guys, if the entire curve represents 100% of the data, what would just this part of the curve represent? 50%, right? Right? That's just half of 100. Right? You guys agree? If it's less than, that doesn't include just 1 standard or 2 standard deviations or 3. That includes all the way to the left, including these super tiny values where it's asymptotic, right? Where it's just getting super close to 0, but never reaching it. Okay, what about this one? What's the probability that it's bigger than the mean? Let's see. I might be able to paint bucket this super quick. Ready? Oh dear, I guess not. Oh dear, that was horrifying. I apologize. Oh, whew, yikes. All right, so yeah, so you can just kind of color these in, right? So this is going to be 1, 2, 3, and all the way forever to that side. What percent of that data is there? Yeah, it's going to be the half of 100 again. Yeah, that would have worked. If I was still on the same layer where I'd copied and pasted it, it also would have worked. But I'm working on multiple layers here. Okay, so those ones aren't bad. What's going to take a little bit of work is just getting used to like this notation. So here, my value of x is between the mean and 2 standard deviations plus above the mean. Okay, so I'm talking this space here. How do you guys think I could find that? Right, it's between the mean and the mean plus 2 sigmas. What are your thoughts? Look at your little chart. I'm looking for this space, which is going to be half of 95%, or I'm looking at this space, which is going to be the 34 plus the 13.5. All right, so that's all you've got to do is compare it. It's actually the same as this one. It was just backwards, right? You guys agree? So this is half of 95%, which is... Yep. Which is 47.5%. Or we could have found it by doing, what was that, 34% plus 13.5%. Still, 47.5% of the data will be there. All right, same outcome either way. I like it. All right, this one, where should I start? So here's my mean. What does this mean? That is one standard deviation less than the mean. So that's right here. So that's the mean minus 1 sigma. So I'm looking for this space. I'll walk around. Let's have you guys try to figure that out. I think so. All right, right on. So this is going to be 34%. Why? Which graph were you looking at? Which picture? So you were looking at the right one, and that's right here, so that's 34%. Does anyone have another approach? A U? No, that's a mu. That's the sigma. Mu, sigma, mu, sigma. So that's the mean and the standard deviation. If I want just this region, this is going to be half, right, of the 68%, which is also the 34%. So that's two ways that I could have gotten that. So this is, yeah, 34%. Okay? Here, let's have, let's look at 5 and 6 as well. I'll have you guys get started on those. You're welcome, by the way, that I gave you these little pre-drawn drawings. Memorize it or use the chart. So you will be allowed to use the chart on the homework and on a test. Question? Ethan, what's wrong? Let's see. Oh, wow, this one's tricky. So find the values of x. This one's not between numbers. This is everything less than the mean minus 1, 2, 3. So guys, this shading is like literally this sliver here that would go off to infinity. Oh dear. Yeah, how could we find that? Let's see, how could I find that? Yeah, right here. That's perfect. 0.15%. So that's less than a 1% chance. Okay. And how about this one? What values of x are bigger than, greater than or equal, bigger than 1 standard deviation above the mean. So that's everything infinitely this way. That would be like this plus this plus this. It's shading all of those. I'll go back in just a second. So it's either this plus this plus this, because this is what was shaded. Or does anyone have another strategy? Well, let's see. I want to describe this data, which is half of this data. This is tricky. Do you agree that this is half of the 2 parts? No? Here, guys, take a look at this. Follow along. The side that I want, right here, going off forever, is half of this. Do you agree or disagree? I just need you to agree with this one step. Do you guys agree? Is this side half of both sides? Yes, Mr. Waddy. Okay, this remaining space is 100% minus the 68%. Okay, watch this. So 100 minus 68% would give me both sides. What's that going to be? That's going to be 32%. And half of 32%, because I don't want both sides, is going to be 16%. Okay? I just wanted to show you more than one way to do it. Yeah, because that gets a little bit tricky. Yep. The way I just showed you is harder to see, but I just wanted to point out you could actually use this version. It was easier just to say, let me just add these up, and that should equal 16%. Is that what you guys got? I'm not going to be able to undo that far enough. That's fine. Yeah, yep. So 16%. And these are estimates, by the way, because we are rounding them off. But that's how it ends up working. All right, last question. This is where it gets a little bit trickier. Example 2. All right, aha, mean 55. So that means my starting value is 55, right? That's my mean. And then they said a standard deviation of 12. Okay? So that means if this is 55, what's 55 plus 12? Yeah, so that's going to be 67. What's 67 plus 12? 79. 79 plus 12? 91. All right, what's 55 minus 12? No. 43, yep. 43 minus 12? So, do you guys see how I did this? Actually, the colors I chose were very specific. I wanted you to think of your y-intercept and your slope. Right, my slope is kind of this plus 12 each time, or minus 12 each time, Ethan, right? And then I can get those values as a result. So now that I have that, it says the following. The test scores range from 0 to 100. All right, that's great. About what percent of people taking the test will have a score between 43 and 67? That's right here. How'd you get that? Here, actually, watch this. This is my cheat move. So here's my original. Oh, dear. Okay, so now that I have those labeled, how'd you get 68%? Yeah. Well, right, if this is my mean, and this was 1 standard deviation above and below the mean, I agree, that's going to be 68%, because you ended up looking at, right, this right here, 68% is 1 standard deviation above and below the mean. Let's take a look at part B. An agency in the state will only hire applicants with test scores of 67 or greater. About what percent of the people have a test score that make them eligible to be hired by the state? All right, so here we go. So 67 or greater is this. So that's everyone that is more than 1 standard deviation, and you remembered that that was similar to what we had just done up here, right? So that's the same as 13.5 plus 2.35 plus 0.15, or all of this work that we did here, it's going to be 16%. All right, so most of this is just a matter of figuring out, right, what part is shaded and what percent those represent. So that means they're only going to hire, or only 16% of people who took the test are eligible to be hired on the basis of taking that test. All right, thanks for watching, mis amigos de Internet.